In this video, I'm just going to briefly describe electromagnetic nature of light and the ability to polarize light. So light is an electromagnetic wave. So what does that mean? There is an oscillation for this in the electric field, which is this blue oscillation here. And perpendicular to it is an oscillation in the magnetic field. So as electric field rises and falls back and forth, there is a perpendicular rise and fall of the magnetic field as well. And light, of course, is going in this direction here. This is the direction that the light wave is actually propagating. So that's why we call light an electromagnetic wave, because it has both oscillating electric properties and oscillating magnetic properties. Now light does oscillate in all directions. If we take a look at light here being produced, it's going in all directions all the way around in 360 degrees. This light is going to be called the incident beam upon what's called a polarizing or a polarizing lens. Now the polarizing lens has molecules or slits that are, in this case, vertically aligned. They could be aligned horizontally in any direction, and you can actually rotate this. And what that does is it blocks oscillations in all directions except up and down. In this case, we're letting the electric field through here, the electric field oscillating through here. And what happens is the light then is not as bright at all. It gets much dimmer. And this is the nature of polarizing lenses in sunglasses. Now, the second lens is called the analyzer. The reason why it's called the analyzer is because we can further reduce the amount of light going through. This one has slits that are oriented horizontally, so now no light's going to get through on the other side here, and it'll be completely dark. Now, if we rotate this lens, okay, as you begin to rotate that up to 90 degrees, those lines are then going to orient themselves just like the lines that are in this first lens, and then all of the light will get through from this side. Now remember, this is already partially blocked, allowing only a little bit of light through. But if you can rotate this lens, you will increase the intensity on this side here. Now again, if you keep rotating it past 90 degrees, you will then begin to decrease the amount of light intensity, okay, measured here. You're going to be doing a simulation that measures light intensity in terms of lumens. And the initial intensity of the light is going to be at the highest possible from the first lens, and then you're going to rotate it until it becomes completely dark, okay, with the second lens and the analyzer. And I want you to discover the relationship between intensity I and the angle of rotation theta. Okay, it is going to involve a cosine of the angle theta. And once you take your data, I want you to try to graph it and get a line of best fit that is a straight line, so as you discover the relationship between the intensity and the angle theta.